All right. Good morning, everyone. I'm a principal architect at eBay, and I'm here to talk about how at eBay Marketplace, for the first time ever, we are using Neo4j GraphDB to solve critical business problems. But before I begin, I would like to ask the audience, how many of you have working knowledge of Neo4j or are using or have used Neo4j for building proof of concepts? Just raise your hand. Okay, great. How many of you are already live in production using Neo4j? Okay, handful of folks. Yeah, great. All right, let's proceed. Here's the agenda. I'm going to introduce the business use case and how we are using Neo4j within eBay to solve for those use cases. And there are key learnings that we've encountered by us being in production for close to 7 or 8 months in live. And we'll talk about some of the learnings that we've garnered by using Neo4j. And finally, what are the next steps? How are we planning on leveraging the graph moving forward in 2018 and beyond? So in order for me to introduce you to browse nodes, I would like to give you some context as to what led to the inception of browse nodes. So back in early 2014, eBay got hit with a manual penalty by Google, which led to a huge dent in eBay's GMB. GMB is gross merchandise bought. So what that meant was that the pages that were ranking in Google search as part of the Google SERPs didn't rank anymore. And what we wanted to do was to mitigate the risk and keeping the long-term goal in mind. The key requirement that we wanted to solve for was having these pages that we conceived of to be navigable both organically. When we say organically, it is for someone who starts from eBay homepage to be able to reach these pages, as well as for these pages to be candidates for SEO landing pages, so that people could have these be ranking as part of these SERPs and for them to land on these pages directly from Google or other search engines. So that was the key requirement. And within eBay, there's a huge taxonomy of categories. So what we did was we coined the term browse node that encapsulates a category and optionally a filter or an aspect. So to give you an example, if you take Canon digital cameras, here's a page that's live that encapsulates digital cameras, belongs to digital cameras category and has a brand Canon applied to it, which we call as a filter or an aspect. So that's an example of a browse node, and we have millions of such browse nodes in our ecosystem. So now that we have conceived of this browse nodes, we wanted to have a mechanism so that we learn from our mistakes and not be penalized again. And we came up with these key success metrics or KPIs that will help us measure our success. So one of the key metric was with regards to discoverability. How are these pages discoverable for users as well as for bots, starting from homepage, and how can we help satisfy the user's buying intent? Okay. The other part of it was ranking. How are these pages ranking in Google and other search engines? Again, so that it can bring about sessions into eBay as well as then the GMB. So that leads us to the last metric of gross merchandise bought. Now, if people were to land on these pages, either organically or from other search engines, how much of transactions are they making from these pages, which leads to GMB. So then there were a lot of use cases that we had to satisfy, and discoverability being one of the key metrics, we wanted to solve for interlinking. Interlinking meaning that from one node, how can I get to other set of browse nodes that are pertinent to the browse node that I'm on? There are two facets to interlinking. Top-down, meaning that if I were to start from the home page, how do I get to these browse nodes? And the other part of it is from a page where you could transact on eBay, whether that be buying or bidding or watching, how can you navigate up back into these browse nodes in order for the users to peruse our inventory and then basically satisfy the buying intent. The other key use case that we had to solve for was bubbling up high-value nodes. So to give you an example, keeping in line with this digital camera use case, if I were to land on a Canon EOS digital SLR cameras, and if for whatever reason these are in vogue and are very popular, and we wanted to have these be available to the users at digital cameras level, or even at the cameras and photos level, we wanted to have these be present as part of some module so that users can navigate easily and quickly to these popular browse nodes. This was the graph epiphany moment for me in terms of being able to understand that this involves identifying all the descendants from a particular node that I'm in, and then being able to retrieve all the descendants and then order them by some rank that we associate with each of these nodes, and then pick the top X. So if we were to do it traditionally through proper, through relational or NoSQL databases, that would entail multiple hops, right? And therefore, we decided to use GraphDB, which is purely graph traversal problem where between 2 hops and 10 hops, I could get all the nodes that are connected to a particular node, and then order them by some score, and then retrieve the top X that I want to show on the module. And there was another use case where in our eBay or the browse node ecosystem, we have another type of browse node called virtual browse nodes. So to give you an example, a wedding is an example of a virtual browse node that has representation across multiple categories. So it's not associated to a single category per se. So if I were to go to wedding, I have representation in wedding and formal wear, wedding supplies, jewelry, shoes, men's suits, and so on. So these are nodes that we created because that satisfies both the users looking for these stuff within eBay as well as from other search engines. So interlinking being a very key for us. How do we again have these be available to satisfy the user's buying intent? So we wanted to have these be interlinked into our ecosystem. So that was another use case that we had to solve for. And the way we did this was both from top-down and bottom-up interlinking. So for bottom-up, we use breadcrumbs, and I'll give you an example of that. So if I were to navigate to, let's say, men's wedding suits, I see that wedding, which is a virtual browse node, being a part of the breadcrumb. Historically, eBay uses its category taxonomy to power the breadcrumbs, and this was the first time wherein we used a graph to be able to walk up all the ascendants all the way up to the home page for us to be able to power these the breadcrumbs. So this entails up to 7 hops, and potentially we could have up to 7 slots for the breadcrumb, and our 99th percentile to be able to retrieve all of these 7 ascendants is in the order of 8 milliseconds. You couldn't possibly do that with NoSQL or any relational database. So with being able to map the problem statement to us having to use a graph database, I went to the other architects within our company to be able to make a case for why graph database is the right solve for the problem, as well as since this was the first time that within eBay marketplaces we were using graph database, I had to go through some of the approval process in order to get the blessing to leverage something for the first time. as well as the hurdles that come along the way for using a technology that's not blessed. So we have to do our own DevOps. If it were to be a supported platform, the first line of defense would be our operational team, and then we would get notified. But with this being the first time we are leveraging Graph Database, there isn't much of expertise within other teams to front some of the issues that might come up. So we do our own DevOps. And in order for you to get the end-to-end picture, there are other technologies that we leverage along with Neo4j to solve the whole business case. That being that our data source of truth is residing in HDFS. So we run Spring batch jobs that take the data from HDFS and then ingest them into the graph. We use Apache Knox in order to have the right security measures so that we are adhering to enterprise security standards. And our REST service is a Spring Boot service that is the one that's interfacing with Neo4j to read and write data. And we use Open Data Protocol to have better expressibility for our clients that are using our REST services to be able to say that, okay, this is the data that I need for the service to return. From an object graph mapping standpoint, we leverage Neo4j OGM. And we have representation across multiple data centers. So we avail the Neo4j causal cluster, and we have a multi-data center license, the enterprise version of Neo4j. And that's how our cluster is set up. Finally, we use custom epoch procedures to be able to connect all of these nodes. Our source of truth only has metadata to an isolated node. There are no connections among those browse nodes. So once we ingest them into the graph, we are then leveraging the epoch procedures to be able to identify the candidates to connect through relationships, and we go about connecting them. This is not a great pattern to use because Neo4j is really good at doing graph traversal. So potentially, if you were to have these relationships identified prior to ingesting the data, that would be the most ideal scenario. And we are working towards maybe using Spark to identify all of these relationships beforehand so that we can then just take those relationships and then ingest them into the graph rather than having to identify the relationships from doing the custom epoch procedures. So there are different use cases that we had to solve for, and I walked you through some of those use cases. But we have implemented in a few of those use cases, and we are already live with regards to some of the use cases that we've already implemented. As I mentioned, we have epoch procedures that we leverage to connect and establish the right relationships among the nodes. I spoke to you about the breadcrumbs that we are powering using the Graph database. And eBay Motors is a big GMB driver for eBay. And we had to solve for some of those use cases, and the way we went about solving was, again, using Graph database. Given the fact that we have these connections among the browse nodes, we were able to have modules on motor-specific pages wherein we could say that here are all the makes, and for a particular make, here are all the different models, and for a make-model combination, here are all the different years. So that for that, again, we leverage Neo4j. And in order for us to solve the top-down interlinking, what we do is we, again, have these hub pages wherein you could navigate to and obtain a list of all the virtual browse nodes or different makes that we have. And those are also being powered by Neo4j. So to give you an example, here is a hub page that has a collection of all the different popular topics or virtual browse nodes. And there are other such hub pages in our ecosystem wherein we leverage Graph to obtain all of these things. So these are just pure label lookups that we do. And there are additional criteria that might have to be satisfied as well. So those are some of the use cases that we are solving for, and here's a snapshot of how we represent breadcrumbs using our service, as well as the shop by model module on our eBay Motors page that help with discoverability. So after we did this, the number of sessions that these browse nodes, the eBay specific browse nodes got, it was like a hockey stick increase in the number of sessions because of the fact that PageRank helps with having the right set of backlinks from pertinent pages, and by us being able to connect all of them together, these started ranking really well in Google, and therefore lend to a lot of sessions coming our way. Here's a pictorial representation of our nodes in the graph. We have an ontology of relationships among all of these nodes. And this being a property graph, we have properties associated with the nodes as well as with some of the relationships. From statistics standpoint, our service gets about 100 million calls on a daily basis, and we have about 80 million nodes and 600 million relationships in our graph database. The size is roughly about 140 gig, and we have each VMs that we have is about 180 gig in memory. So right now, everything is stored from within memory and served from memory. I mentioned about availing causal cluster. The way our cluster is set up is that we have representation across 3 data centers, and within each data center, we have 2 core members and 2 read replicas to scale the reads. Some of the key learnings that we found out, some the hard way, some through early engagement, is graph modeling is really, really key. It's really different to how you model in a relational world. So it's extremely important that you get trained on graph modeling so that you have the right model in place that can serve the use cases in a timely manner and therefore enable you to be successful. If you go to production, you definitely need monitoring and alerts, and Neo4j uses GraphI to kind of obtain all of the data, and on top of that, we leverage Grafana to be able to visualize the dashboards as well as to alert us if things were to go wrong. If you're using OGM, or sometimes if you're doing stored procedures to ingest data, there's a notion of implicit transaction. So if you don't use explicit transaction, there's a transaction that gets created, and there will be a transaction associated with a thread. So I encourage you to use explicit transaction. The reason being that for some of the stored procedures that you write to ingest data, if you don't use the proper implementation pattern, that could cause the memory to bloat and potentially the cluster to go down. So there's a very good blog by Max DeMerzi on stored procedure to import data. I recommend that people go through it and make use of the implementation pattern if you are to use a custom procedure to ingest data. And finally, Neo4j uses distributed consensus, or Raft, to have all of these core members partake in replication and being able to serve and be available, right? So distributed consensus in itself is quite hard. So I'd encourage that you go to the nitty-gritties, understand the nuances of Raft, so that you understand how replication works. And some of the configurations that you have to do on Neo4j, you have to fine-tune it based on the data size that you have. So if there is huge amount of data size that you have within the graph, sometimes as the core members come up or the read replicas come up, the entire data set will be shipped over from a transaction standpoint from the leader over to the follower or the read replica. So you need to have the right connection timeouts configured in order for you to be able to have the follower or the read replica be in a position to take all of the replicated data. And finally, when it comes to routing, especially if you're leveraging bold plus routing, there is an inherent routing table that gets stored in order for the cluster to be able to understand what are all the core members that are serving the reads, as well as who the leader is, and then who the read replicas are. And as part of the VM coming up, you need to have the initial connection URI configured so that the first time it's able to talk to the right core members that is configured as part of the connection URI to be able to retrieve the routing information. If, for instance, you were to have that connection URI be pointing to a specific core member, then if that core member is down, the VM will not come up. And secondly, if it is already up, the routing information will never get refreshed. So it behooves you to have that connection URI be pointing to a load balancer that then encapsulates all of the core members, so that even if one core member is down, the routing information can be obtained from other core members. What are the next steps that we have to focus on? From an SEO standpoint, the graph becomes a critical component, and most of the features that our product managers come up with are on graph. So we are going to be using this graph to ingest more nodes to support different sites, and that would bloat the graph or increase the number of nodes to roughly 200 million. We also have plans to have other types of nodes, what we call as products, be ingested into the graph, and that will increase the number of nodes to roughly about 750 million or close to 1 billion. And since we have a lot more applications leveraging the graph, we have to scale our service and Neo4j to be able to support 1 billion hits on a daily basis. And we have to work with Neo4j in order for us to be able to rightfully manage and have the right topology for our causal cluster so that we can satisfy those things. And I'm really excited about the feature that they announced in 3.4 with regards to having the multi-data center cluster and having the clusters talk to each other. So I'm really looking forward to that capability. We are looking to migrate to a new data model to support some of the additional use cases that our product managers have come up with. And finally, as I mentioned, sharding is important because of the data size increase. We would definitely need to have better sharding capabilities or better management of the cluster so that we can serve all the different use cases that we have to cater to. That's pretty much what I have for the time. Thank you.